So hello all of you. Uh, Here today we'll be extending our discussion on spin. In fact, we have already talked about Pauli's spin matrices, and here in this lecture we'll take on a problem. We'll take on a problem and we'll try to calculate the probabilities. I mean, if I start with, so we have been taking into account the spin, and I take on the state psi. If I take this state psi equal to 3 by 5 spin up uh, plus 4 by 5 I spin down. So we'll take this problem and we will try to calculate the probabilities. I mean, we would like to calculate the probability of getting spin up along x, the probability of getting spin down along x, the probability of getting spin up along y, and then probability of getting spin along spin down. So in order to do that, so we can see that this state psi is 3 by 5, 5 of spin up plus 4 by 5 I of spin down. Now, if so what are the things that I'm interested to calculate is basically I want to calculate, say, spin up psi p spin up. What will be the probability that will be calculated to have spin up, and that can be that will be the square of the mod of spin up with the state psi. Now, moving on from here, what I can do is I will take on my. So we better understand that spin up along x, its ket is 1 by root 2, 1 by root 2. So this implies the bra of spin x will be 1 by root 2 and 1 by root 2. Now, what should I do here is, if I take on this this bra of spin up on x, I act it on psi. So this is what I'm supposed to do. So for the bra of spin up along x, that is 1 by root 2, then 1 by root 2, and psi, the ket of psi, as that's given in the given problem, that is 3 by 5 and 4 by 5 I. So what will be that? That will be a column matrix of 3 by 5 and 4 by 5 I. Okay, so this way we can calculate, we can have the product between the bra of spin up and the ket of psi. So on calculating this, what we'll get is spin up and psi. This will be 1 by, let me repeat it, this is 1 by root 2, this is 1 by root 2, and this is 3 by 5 and 4 by 5i. So what will we obtain from here is 3 by 5 root 2 plus 4 by 5 root 2i. So this is spin up on the state side. Now, what is it that I have to calculate from this problem is that I have to calculate the probability of having the probability of getting spin up. So in order to do that, I have to calculate the probability. So if I have to calculate the probability, that probability of getting spin up will be spin up and psi, and this part is already calculated. So if this part is calculated, so what I will have is 3 by 5 root 2 plus 4 by 5 root 2 whole square. So 5 root 2 can be out, so we have to take the square of that. So that will be 25 times 2, and then you will have 3 plus 4 iota. Alright, so I think this should be clear to everyone. So on moving from here, what we are calculating is probability of getting spin up. So that will be 1 by 50, then you will have 3 square plus 4 square. Okay, because you have to take the complex conjugate of 3 plus 4i, that will be 3 minus 4i. When you multiply the two, you will come up with 3 square plus 4 square. So here we can see that probability of getting spin up will be, this is 9 plus 16 by 50. So probability of getting spin up is, this is 25 by 50, and 25 by 50 is simply 1 by 2. So in this problem, the probability of getting spin up along x is 1 by 2, so that means it's 0.5%. Now, extending out the same discussion on getting the probability when we have spin down along x. So for that, I'll be doing the same calculations. So what I'll do for that is the draw of spin down along x, then the state psi. So this will be what. So we have the draw, as we know that the ket of spin down along x is 1 by root 2 and minus 1 by root 2. So you change it to the draw of spin down will be 1 by root 2 minus 1 by root 2. So we can repeat this. We can repeat this act, and what we are calculating basically is spin down on x on psi. So what I will have 1 by root 2 minus 1 by root 2, and for psi, what I have is 3 by 4. This is 3 by 5 and 4 by 5i. So let's have the inner product between the spin down along x with this state psi. So what I'll get is 3 by 5 root 2, and then I'll get minus 4 by 5i. Okay, it has to be 5 root 2. So this is my spin down along x psi. Right? Now, what am I supposed to do here is to calculate that probability. The probability of having spin down along x. So if I write that as p spin down along x, that's going to be spin down along x state psi, its whole square. Fine. So this is already calculated. How much is this? This is 3 by 5 root 2 minus 4 by 5 root 2. So we have 3 by 5 root 2 minus 4 by 5 root 2, then I have I. Alright, so we can see here the probability will be same in this case, because so outside I'll have 5 under root 2 whole square, and inside I'll have 3 minus 4i whole square. So the probability of getting spin down on x will be This is 1 by 50 times. So here again, you will have the complex conjugate, and the result will be 3 square plus 4 square. So P spin down is, it is 25 by 50, and this is going to be equal to 1 by 2. So P down x is 0.5. Now let's take on this problem to a component along y. So I would like to calculate the probability of getting spin up along y. So for that I have P spin up along y. So if I have to calculate this, it certainly will be spin up and psi whole square. This will give me the measurement of the probability of having spin up along y. So in doing so, what I have, so here it has to be y. So as we know from our reference, the reference is what? Spin up along y is, it's 1 by root 2, and then it is I by root 2. And this is the ket, so it's bra, the bra of spin down, spin up along y. So the bra of spin up along y is going to be 1 by root 2 and minus I by root 2. Fine. So we have the bra of spin y, and we have to act this. This has to be bra. Okay, this has to be bra. I'm sorry. So this is bra of spin up along y. So in doing this, what we'll do is we will act this this bra of spin up along y on my state vector. So in doing so, what I'll have spin up along y. It has to act on psi, and psi is already defined in the problem. So this spin up along y and the state psi, this is going to be 1 by root 2 minus I by root 2 times the column matrix of psi, that is 3 by 5, then 4 by 5i. So what we'll get 3 by 5 root 2, and here we'll get, this is iota square is minus 1, and minus will be plus, so this will be plus 4 by 5 root 2. Okay, so we can see that in this case we have got the rid of iota. There's no iota. So what am I supposed to do is to calculate this probability of spin up along y. That's going to be spin up along y. Then you'll have psi, its whole square. Will give you the probability of having spin up along y. So that can be written as, so what will be that? That will be P spin up along y will be, yeah, so this is 5 root 2, 5 root 2, and 3 plus 4. So this is 3 plus 4 divided by 5 root 2 whole square. So this is 9 by this is 9 by 5 root 2 whole square. So 5 will give us 25, and this will be the 9 square. Now this is 4 plus 3, that's 7. So here you have 7, and in the denominator it has to be the square in the numerator. Then in the denominator 5 square will give us 25, and root 2 square and root will cancel, you'll get 2 here. So you'll get 49 by 50. So probability of getting spin up in the given problem will be 49 by 50. And we can resolve it, so 50, So 49, so 0.0, and it will be nearly 8. Now it has to be 9. So 0.9. So the probability of getting spin y along spin up along y is going to be 49 by 50, which is nearly equal to 0.9. So this will be the probability that will measure that this spin up along y will measure. Now we can extend the same thing for spin down along y. So spin down along y acting on psi, and I can write down this as it has to be 1 by root 2. So in that case I had minus here, I'll have I by root 2 simply. So you will have a column vector for psi, that's 3 by 4, and then we have 3 by 5. Okay, then we have 4 by 5i. Okay, so what we'll get is we'll get 3 by 5 root 2, and then you will have minus either scatter will give me minus 1, so this is minus 4 by 5. So that is my spin down along y acting on psi. So what am I supposed to do is to find P spin down along y is going to be the square of spin down along y and state psi whole square. Now this thing is already measured, and all we have to do is to take its square. So 4 minus 3 will give me minus 1, and this has to be 5 root 2 here. So the probability of getting spin down on y will be minus 1 by 5 root 2 whole square. So this is 1 by 25 times 2. So this is 1 by 100. No, it's 1 by 50. So the probability of getting spin down along y in this case will be 1 by 50. So we can calculate this 50. So this is 1.0 and 0. So this is 0.02. So probability of getting spin down along y is 0.02%. And this is how you can proceed in a given problem, and you can calculate the probabilities, the probability of getting spin up along z, and the probability of getting spin down along z. So with this, I would like to end this discussion. Basically, I chose this problem to have a clear idea about how we take on the problem of spin and how we calculate the probabilities of getting spin up, spin down in terms of the coordinates.